The rock looked wrong, not dramatically wrong, not in a way that would make headlines on its own, but the scientists studying the image knew what they were looking at, and what they were looking at had no clean explanation. Round, dark spots, each one ringed by a faint pale halo. The kind of pattern that, on Earth, is produced by living things metabolizing iron in ancient rock. The kind of pattern that geologists recognize from places where microbes once existed. The kind of pattern that, on Mars, had never been seen before. The rover that found it was the most sophisticated machine ever sent to another planet. And in the summer of 2024, that machine sent home an image that NASA's own scientists described using a phrase they had never applied to a Martian sample before: potential biosignature. They did not say life. They have not said life. But they said those two words together in a peer-reviewed paper published in the journal Nature and in the history of space exploration that had never happened. Perseverance landed on Mars on February 18, 2021. Its target was Jezero crater, a 45-kilometer-wide impact basin in the planet's northern hemisphere. Scientists chose Jezero because satellite imagery showed something unmistakable: the ancient remains of a river delta. Billions of years ago, water flowed into this crater from the surrounding highlands, deposited sediment in a fan-shaped formation, and filled the basin with a lake. The lake existed for hundreds of millions of years. The water is gone now, has been gone for more than 3 billion years. But the geology of where it once was is still there, layered in rock, waiting. Perseverance spent its first years drilling, analyzing, and caching rock samples across the crater floor. Most of what it found was interesting but ambiguous: volcanic rock, sedimentary formations, mineral deposits consistent with a wet, ancient environment, consistent with life having once been possible, not consistent, in a direct sense, with life having once been there. Then, in July 2024, the rover reached the edge of the ancient delta and found a rock that was different. The rock was named Cheyava Falls after a waterfall in the Grand Canyon. It was roughly a meter long, the largest sample Perseverance had ever drilled, and pale, almost white, with rust-colored veins running through it. The kind of rock that forms when water moves through cracks in stone and deposits minerals over long periods of time. But it was what was on the surface of the rock, embedded in it, preserved in it, that stopped the science team. Spread across its face were irregular dark spots, each one roughly the size of a small coin, each one surrounded by a lighter ring. They looked like markings on an animal's skin. The team called them leopard spots. On Earth, this exact pattern forms in iron-rich rock under specific conditions. Microorganisms, specifically certain types of bacteria, metabolize iron as an energy source. As they do, they create localized chemical environments that dissolve the surrounding minerals differently than the host rock. The result is a halo, a dark core of microbial activity surrounded by a pale ring where the chemistry changed. Geologists call these structures by several names, but they recognize them. They have found them in ancient seafloor rocks, in Precambrian iron formations, in exactly the kinds of environments that once existed on Mars. And when they analyzed Cheyava Falls for organic compounds, the carbon-based molecules that are the building blocks of life, they found them, not somewhere else on the rock, in the same location as the leopard spots, spatially correlated, sitting together in the stone as if they belonged there. The paper, published July 25, 2024, was authored by a team that included some of the most respected planetary scientists working today. They were careful. They wrote with the kind of deliberate restraint that scientists use when they know the stakes are enormous. They outlined two possible explanations. The first, the leopard spots and the organic compounds were produced by microorganisms living in the rock during the period when Jezero crater held liquid water roughly 3.5 billion years ago. The second, the pattern was produced by abiotic chemistry, specifically a process called serpentinization, in which iron-rich minerals react with water at high temperatures to produce organic compounds without any biological involvement. They listed the evidence for both. They said they could not determine which was correct from the data they had. And then, in language that had never appeared in a NASA Mars science publication before, they described the leopard spots as a potential biosignature. Not a confirmed biosignature, not proof, but the phrase carries meaning in astrobiology. A biosignature is a feature that could have been produced by life. The word potential means they cannot rule it out, and cannot rule it out when the alternative explanation is also possible, but requires specific conditions that are harder to verify, is a scientific way of saying, we are looking at something that might be the remains of ancient Martian life, and we do not yet have the tools to know for certain. There was immediate debate. One of the paper's own co-authors, Benjamin Weiss of MIT, wrote a companion piece in Nature, arguing that serpentinization was the more likely explanation, that the patterns could be produced abiotically, and that extraordinary claims require extraordinary evidence. He was right. They do. The problem is that extraordinary evidence, in this case, is sitting in a sealed titanium tube on the surface of Mars, waiting for a spacecraft that may never come. This is where the story takes its most difficult turn. The entire Perseverance mission was designed with one goal: collect the most scientifically valuable samples ever obtained from another planet, seal them in tubes, and leave them on the surface for a future mission to retrieve and bring to Earth. That mission, Mars Sample Return, would have brought 33 sealed tubes back to laboratories where scientists could use every analytical tool available, techniques far beyond what any rover can carry, to determine definitively whether the patterns in Cheyava Falls were made by living things. Mars Sample Return was planned, it was funded, and then, in 2024, NASA announced that the mission was over budget, behind schedule, and would need to be fundamentally restructured. The projected cost had ballooned to $11 billion. No launch date was confirmed. The tubes sit on Mars. The rock named Cheyava Falls was drilled, sampled, and cached. The sample is there. The answer might be in it. And right now, we have no confirmed way to get it back. Consider the moment this represents. 3.5 billion years ago, Mars had liquid water. It had a dense atmosphere. It had volcanic heat driving chemical reactions throughout its crust. The conditions were not dramatically different from the conditions on early Earth at the same time, the period when life first appeared on this planet. The question of whether life arose on Mars during that window, alongside life on Earth, or even before it, is not a fantasy. It is a serious scientific question that serious scientists take seriously. And a rover has now found, in rock from that exact period, a pattern that on Earth is made by living organisms, in spatial association with the organic molecules that living organisms are made of. We do not know if Mars had life. We do not know if it still does, deep in the subsurface where liquid water may persist, shielded from radiation. We do not know what the leopard spots in Cheyava Falls actually are. What we know is that we found them, and that they are consistent with biology in a way that nothing found on Mars before has ever been. The word potential is doing a lot of work in that sentence. It is doing exactly the work it is supposed to do. It means we haven't ruled it out. The tubes wait. They sit on the rust-colored surface of an ancient lake bed, filled with the compressed cores of the most carefully selected rock samples in human history. One of them may contain the answer to the oldest question we have ever asked. Whether we find a way to bring them home is not a scientific question. It is a question of will, of priority, of whether we decide that the answer is worth what it costs to go and get it. Somewhere on Mars tonight, a sealed titanium tube is sitting in the dark, and inside it, there may be something that was once alive.